Okay, so let's continue where we left off. Let's open Unity. Right, let's continue our asteroid generator. Okay, everything works well. And let's go. Okay, so I tested the code. Let me double check and see. Probably not this. Place object. And oh yeah, there was this bug because of which I was spawning these asteroids the same distance, so without colliding, but there was this one in the middle. This is an easy fix. Easy peasy. And then I can commit the code. Yeah, it should just be this. There was also to do. All right. So this is needed. Yeah, I can see why. So you know what, for the moment I just save it as is. It's not a big deal because I'm not done with the algorithm. To spawn. Inside the cube. I'm not gonna mention this this bug. Yeah, I know, there's a turbo. And push. I mean, I don't want to feel guilty. Back. Cube is. Okay. Let's go. Now, let's do the same, but for Y and Z. Such a mess. So this is actually a constant. I see. Mm-hmm. Okay, sorry. I want stuff in line, not like this. Good. Oh, good. Save and test. Oh, so they don't touch each other. Good. Of course, this looks terrible, but yeah, we still need to make it functional. And actually, I want to make it smaller because it's, yeah, let's do 15, 15, 15. And let's not do magic numbers. Okay. But it works, so I'm gonna commit. Accesses? What's the plural of access? Access. Okay. What is this? Oh, I'm amending. Okay, so now well, we have a problem of readability, but I'm gonna fix it when I'm done. So now, what I wanna do is to make this a variable. Okay. Give me a second to think. Yeah, let's work on the making it variable. So what's the thing? This is not fixed. This part here should change. But what's the logic? So I want a list of other stuff. So let's use some. Okay, so let's go step by step. First of all, I want to remove this and use a list. And to make it work, I need to so wait. I need one enable or and this list is already populated with what I need from this vector. So I just need to change the logic. So let's do simple logic show. For example, show. So I need to see how to do this in C#. I think it's like this. No? In. No. How to well, oh yes, right, it's for each. So for each no, this cannot work because I need to select it inside. Wait a second. A while would be better. prefab index. However, count, yes. So if my index is more than this, then we do prefab. Oops, 0. So for the moment, this is the prefab. Just as a test, you know. So let's do them to show. Oh, let's make it clear. 1.5, 5, and then okay. And now I want to do a big one. And this is like 2. Let's do 3. Right? Why do I want to do this? I want to do this because I want to test the list of prefabs and check if this works as intended. What did I do? Mistake. We have small, medium, big, and should make it bigger, probably. Oh wow, lag. Okay, they're all small, so there is a problem. There is a problem here. So it starts with 0. Every time we create a new asteroid, we do this. Okay, maybe probably the problem is here. Let's see. But I already can see that it's lagging. Wait, what? Interesting. Okay. So sometimes it really doesn't throw an exception. But maybe let's go step by step, shall we? And yeah, smaller. Wait, is this smaller? Oh, that's why. I can see what the problem is. Wrong place. It should be here. They're all small still. Course. Oh, wait a second. I need to do this. That's why. Okay, let's do it again. Yeah, I can already see. That something is happening here. And the thing is, sorry, the thing is, I am, I can explain this. We are dividing. Okay, well, let's explain it another way. This is based on, so this value is based on current prefab, which is the first element. Now, that means that it will use this to, give me a second, but that means that they stay inside each other, or in fact they do stay inside each other. Let's do, so there is a faulty logic, and the reason for this is that this should be a variable depending on this guy here, not on the first element. So for the moment I make this is temporary. I just want to save the state of this code. And then I amend it. So that means this guy here should be here too. Yeah. As well as this. And this will make sure that the first time, on the first iteration, this level is fine. But every time we go to the next, we want to place the next object, then keep in mind that the next object might be of a different size. Why is this important? It's important because after I place the first object, the second object will be different. The offline zone radius will be different. And what it means is that this value here is also different. And so, and based on that, object will not be placed on a grid, but will be placed based on, they will appear kind of random, let's say, because they are based on a variable. So if this is a big list, the placement should look random. That's right. I can already see that there is a bug, don't I? So, let's see if this is first of all, should be divided by 2. So it should be multiplied diameter. Right? Because the distance should be based on the center. The distance from the center. Yes. Not fully convinced. So yeah, this makes no sense. But I don't want to do this for now, because there is another problem. And it will change everything here. So the thing is, this works only for distancing an object, the initial object, to the next object, but it doesn't work for distancing, for example, the object that is up or down, sorry, over or under, or on the side of the current prefab. What we should do actually is find the largest radius inside this list and use this just to be safe. from previous. No, wait a second, I should amend this. Distance of each second of this right is over the previous object upload from the objects over. Does that make sense? So what we want to do is to take this we call it max title, and we should find the biggest element inside this list. So which prefab we prefab take this equals to 0. Is bigger than x. Then x. I'm sure I can use strings to find the biggest. I mean, I'm not sure if it's like Java. Not really. I don't know. I don't really want to investigate further for the moment. So we find the biggest. Oops. Why not? Why? So we find the biggest, and there was the biggest here. In that way, we are absolutely sure that each element won't touch it's to 30. and still. I'm sure it might make sense. So let's do this on a large scale. Let's do 100. I hope that my gonna be probably alright. The wrong way. Yeah. So this is quite big. No, there is a bug. Why? It stops on the third element, apparently. It's not config. Okay, talking about. Oh, right, doing this. Still need to choose them first. Yes, and in what one? I define it here. No, will make much sense for me. Are they the same? Or they are not? And this can be found only inside. I just leave 0 to make it more clear. But yeah, it should be 0. So how can I fix this? I make this a look good. I mean, I don't even need this, to be honest. Yeah, problem solved. And was wondering also why it's so laggy when I have so many objects. Nope. It stops on the third. Okay, so let's select step first. Create a new asteroid. That's this. Prefabs amount and count, then this becomes 0, right? Then I change the next prefab. So this shouldn't be here anymore. Yeah. Such an easy idea, you know, of a script. Creating so many issues. Oh, now they're also in the wrong position. Oh my god. Why I found. Wait, what? Oh, this should be here. Just find it once. Okay, so now there is a problem of distance, apparently. Because the biggest is 12. What's the result of this? Oh, sorry. 4. Definitely not what I want. So we start with 4. We check prefab 0. Oh. Wait. That's fine. I fall for it. Allergic killing. Yeah, now it works. Nice. So apparently the distance is correct now. But still stops at 3 elements. Why? And then let's debug. Okay, 0. Right, the next is 1. This needle. Okay. The next one is the doomed one. This is 3. It doesn't throw an exception. Oh, yes, it does. Yes, it does. Solved. As easy as that. Oh my god, the lag. Why is it lagging like this? It works. No complaints. Does these guys have no code? Does the game lag? Oh. It's lagging. But the algorithm is correct. So can now do this. Squash. Push. But now I want to say, okay, move it. I don't know if this is like something to do with mods. There are details. Because like wow, the memory. Can I remove some stuff in the background? Wait, I have things in the background? No. Great. Still lagging. Tror jag till stigant. Wait a second, what if I make them static? So, no, it's not a thing. Use features like dynamic resolution can help reduce overload. Let's see how this works.
When making levels, you of course want them to be as detailed as cube as well, and hit D for level of D to the top and rename to LOD2. And again, I'm gonna hit M to move it on to another layer.
Let's do something as Unity profile, because I want to see where the problem is.
In this video, we are going to look at the Unity Profiler. Profiler is for creators who want to enhance their projects by implementing optimization techniques to improve gameplay performance. It is generally recommended to set a target frame rate for your gameplay for benchmarking against during development. Depending on the specific check gameplay performance, we can now open the profiler from Window, Analysis and Profiler. The profiler is ready to record, so as soon as I begin playing, it will now begin recording frame by frame data. This is all CPU data. At any point, I can click in CPU usage to pause the game and analyze this frame. We can see that these frames are running higher than 5 milliseconds but less than 10 milliseconds, which puts it somewhere between 100 to 200 frames per second. This game is currently not maximized. This can make the game look more performant than it really is. Where possible, profiling should be done at the desired resolution the game is meant to be played at. If you intend for multiple resolutions, then it is better.
Blowing my nose. Yeah, sorry, my allergy is killing me. I took advantage of this short break to eat a banana and take a drink. I hope it doesn't make noise. But we need to watch the videos now.
Better to profile.
Hello?
In this video, we are going to look at P. A quick way to check gameplay performance is to use the stats option in the game view. This will display current FPS. Now this game is very well optimized, giving high frame rates on the desktop computer. To understand what is happening each frame, we can look at the order of execution for event functions.
Interesting. Let's do this. Stats. Where is stats?
What is happening, giving high frame rates on the desktop computer.
Yeah, cannot find it. Oh, it's game view. Yikes. My bad. So let's do without. So not full screen. Right, main forming sequence. That takes so many. I have nothing. Let's enable 10 FPS. 50 patches. It's 500 patches. Yeah, a lot of vertex. Play loop. Don't know what this means. So let's continue.
Computer. To understand what is happening each frame, we can look at the order of execution for event functions on the Unity documentation. Here is the game loop that happens every frame and comprises physics, input events, game logic, scene rendering, GUI rendering, and end of frame. These are shared between the computer's CPU and graphics card's GPU, which must work together to render the frame. For a target frame rate of 60 frames per second, it must render every frame at 16.66 milliseconds or less. And for 30 frames per second, it must render every frame at 33.33 milliseconds or less. The CPU handles the Unity engine code and your own code as part of game logic. The Unity engine code and your own code as part of game logic. The render commands are passed down to the graphics card GPU to render the frame. Some frames may struggle to render at less than 16.66 milliseconds. The CPU may take longer to run the game logic code, creating a CPU-bound bottleneck. The graphics card has to wait until it receives the render instructions from the CPU. The GPU-bound bottleneck happens when the GPU takes too long to render the previous frame, forcing the CPU to wait until the GPU is ready to render this frame. And Profiler. The Profiler is ready to record, so as soon as I begin playing, it will now begin recording frame by frame data. This is all CPU data. At any point, I can click in CPU usage to pause the game and analyze this frame. We can see that these frames are running higher than 5 milliseconds but less than 10 milliseconds, which puts it somewhere between 100 to 200 frames per second. This game is currently not maximized. This can make the game look more performant than it really is. Where possible, profiling should be done at the desired resolution the game is meant to be played at. If you intend for multiple resolutions, then it is better to profile each resolution in turn. CPU data is a combined view of all these categories, which are color mapped to the colors in the timeline view.
Okay.
We are profiling inside of the Unity editor, so the running of the editor is combined with the running of the game. The others category contains the Unity. We are profiling inside of the Unity editor, so the running of the editor is combined with the running of the game. The others category contains the Unity editor data alongside other things. It is much better to profile from an exported game which doesn't contain the Unity editor data and gives more accurate results. We will cover that a bit later. Any of these categories can be viewed in isolation to analyze individual performance. I will maximize this to see this better. There are numerous modules running such as rendering, memory, audio, video, etc. These can be switched on or off as needed. There are numerous modules running such as rendering, memory, audio, video, etc. These can be switched on or off as needed. Click on the spike to analyze the results. The timeline section is going to give us an in-depth look at what is happening during that frame. Click here and press the A key to frame all. This frame took just 9.73 milliseconds to complete, from 0 to 9.73. This is showing us horizontally the timing of each CPU thread in this frame. The main thread is the CPU data, and the render thread.
Okay. Okay, so now the frame rate is 200 to 1.4 milliseconds. Okay. Mm-hmm.
Is the render commands to be sent to the GPU. The CPU data and render threads are both taking place on the CPU. The CPU data thread is handling the game logic and the render commands. We can see here the game logic code and the render commands, which are passed over to the render thread ready to pass onto the GPU to render the frame. We also can see here the game logic code and the render commands, which are passed over to the render thread ready to pass onto the GPU to render the frame. We also have this editor profile marker because we are profiling inside of Unity. We can click on the profile marker and press F to frame it. This is the update script run behavior update, and it took 0.26 milliseconds to complete. If a CPU thread was taking too long, we could identify it here and work on fixing it. The CPU is also handing some data down into the jobs section. This makes use of the processor core.
Yeah, this very skyrocket. I wish I could see more. Like more extended. So others 20 milliseconds. This takes 20 milliseconds. This takes nothing. Nothing. Mission. Okay, physics. Physics. I'm still very low. Scripts. Yeah. Clearly, it's a problem with rendering. 76 milliseconds. physics, behavior update, physics. Let's keep watching.
Multi-core threading to speed up CPU processing. Each worker corresponds to a separate worker thread that is responsible for running jobs concurrently. The number of workers you see depends on the number of available CPU cores on your machine and Unity's threading settings.
Do I have jobs? Yes. So this is like the entire frame. Took eternity. My console. Sorry. No. So this is the previous frame? No, it's the same frame. 75 seconds of frame loop.
It can give insights how effectively Unity is utilizing multiple threads to parallelize the execution of jobs. This can lead to improved performance on multi-core systems. We can click on the profile marker and choose to show in hierarchy. This moves us over to the table-based hierarchy where it presents each process in the parent-child structure. This process took 34.5% of the entire frame time to complete.
Interesting.
We can also choose to view any of the available threads, such as render thread, to analyze more data. The table data can then be sorted based on highest and lowest values, making it easy to identify which CPU threads are taking the most time to complete. We can use the drop-down to jump back to the timeline. Right-click on the Profiler tab to enable colorblind mode if you are finding it hard to see the data. VSync is used to prevent screen tearing. Here is an example of screen tearing. The top part of the frame has not finished processing. The graphics card renders the part it currently has and uses data from the previous frame to render the missing part at a visible tear between the two frames. VSync forces the graphics card to wait until it has complete frame data before rendering a frame. Screen tearing is then eliminated. VSync is enforced on mobile devices. but on desktop computers, it is an option that can be switched on or off. If I enable VSync, we are going to get very different data to what we saw previously. I will clear this data and begin playing again. We can now see the frame rate is capped at 60 frames per second. VSync is forcing the CPU to take the full 16.66 milliseconds to process data, preventing screen tearing. In the timeline, we can see an extended editor loop profile marker. This is forcing the CPU to take the full 16.66 milliseconds before processing the next frame. Now this is an example of a well-optimized game, but let's look at an example that has no optimization. This example scene is designed to put a lot of stress on the CPU and GPU. Each of these cubes have several real-time lights with shadows. Now adding more real-time lights in the scene puts more stress on the GPU. There are spawn points that spawn in spheres that have rigid body physics. In the script we can see the spawning happens every frame, but within that is a for loop that spawns 10 spheres per spawn point per frame. This will put a lot of stress on the CPU. The spheres are destroyed after 4 seconds. And I have a debug.log in a rotate script that returns a string reference every frame. Now this will put extra stress on the CPU. We now want to profile this externally, which gives the most accurate results. In the build settings, ensure this scene is in the build. The development build should be checked on and Auto Connect Profiler also checked on. In the player settings, I have set this to a player window of 1280 by 720 and running background is unchecked. Now I can build the game. With the profiler open in Unity, I can now run the external build. And we can see some spikes pushing the frame rate below 30 frames per second. Let it run for a few seconds and click to pause on a certain frame. Now generally most of it is running just above 30 frames per second, however these spikes are causing a frame dip. This frame took 80.66 milliseconds to complete. This first section is internal Unity scripts and physics, and this part is my scripts. And these are the render commands which are passed down to the render thread and then onto the GPU. My scripts are taking up the largest part of the frame, but the physics in orange are also taking up a big part of the frame. Physics run at a fixed update that will be much slower than the update. Because I am spawning in a large amount of spheres every frame with rigid body physics, the physics has to run to catch up with the update, causing some frames to have these large spikes as it runs larger amounts of physics updates. The render thread is having to wait 70.33 milliseconds before it can render the frame. This is a CPU bound bottleneck. This rotate update is taking 48.55 milliseconds. Let's see this in the hierarchy. And we can see this is all because of that debug.log. The physics is taking roughly a quarter of the entire frame. We can now see where the issues are and what needs to be fixed.
Right, so if we do this, local machine, hold it to
This example every frame results. I want to profile this externally, which gives the most accurate result.
okay, yeah, build setting. What is this build profile? Oh, okay.
In the build settings, ensure this scene is in the build. The
Oh, right, auto connect.
development build should be checked on and Auto Connect Profiler also checked on. In the player settings, I have set this to a player window of
Play settings.
12 also build. The development build should be checked.
Oh, sorry, give me a second. Oh shit. I wanted to spawn the asteroids. Now I want to build. So build a one again. Sorry. I don't get it.
Checked on, and Auto Connect Profiler also checked on. In the player settings, I have set this to a player window of 1280 by 720, and running background is unchecked. Now I can build the game. With the profiler open in Unity, I can now run. Now I can build the game. 20, and running background is unchecked. Now I can build the game. With the profiler open in Unity, I can now run the external build.
Okay, so we just need to do this. Yeah, there is a problem. Uses the custom editor, does not inherently editor. So that's the problem. Then let's just do this. Should be fine now. Okay, why did it fail? Is it because of rider? Mm. Mm. Okay, target back. Okay, so you know what? I had a moment of reflection. We don't need to profile. I already know what the problem is. So, and actually, what I wanted to check also was so there are no code changes apparently. I can just reset. Also want to push this issue. Oh, it's already up to date. Okay. What if I make them static? frames are less patches. FPS is more stable. But still, many vertexes. Empty. So here we have uh, 228 million. There's an article. Yeah, what is it very old? My graphics. Okay, I mean, let's keep in mind these values. All right, yeah, I'm keen to learn how to do the script. So Unity, something more recent. Okay.
One of the best ways to optimize a game is by using LOD or level of detail. What is LOD? You've probably noticed in some games that when you view buildings or objects from a distance, their quality is lower than when you're up close. That's LOD in action. Low quality at a distance and high quality when close. That's LOD in action. Low quality at a distance and high quality when close. There are two main ways to implement LOD. The first is to create LOD models in Blender, and the second is to set them up directly in Unity. For example, you can create LOD models in Blender, export them as an FBX file, and import them into Unity. Here's how it looks. The FBX object will contain several child objects, each with a different level of quality. These objects automatically come with an LOD group component, and you can adjust their settings in Unity Inspector. I'll explain how to use the LOD group component and you can of quality. These objects automatically come with an LOD group component, and you can adjust their settings in Unity Inspector. I'll explain how to use the LOD group component in more.
Oh, that's the first time I see this. Right.
More detail later. The second method is to create an LOD group directly in Unity. How does this work? Imagine you have a building with 4 versions, each with progressively lower detail and quality. First, make these 4 version objects child of an empty game object, positioned at a fixed point. Select the parent empty game object and add a LOD group component to it. Parent empty child of an empty game object, positioned at a fixed point. Select the parent empty game object and add a LOD group component to it. Now, how do we use the LOD group? Let's start by going to the scene tab. You have a main camera in your scene which you can move around. With the LOD group, you can control which version of the building is displayed based on the camera's distance from the object. Here's how it works. LOD 0 is the highest quality, used when the camera is very close to the building. Drag the camera in the LOD 0 field and assign the highest quality model to LOD 0. Move the camera farther away, then assign the slightly lower quality model to the next LOD level. After it, assign the third model to the next LOD level. Need to add a new LOD level? Simply right-click in the LOD group component and select Insert Before. Now, as you move the camera, the building's quality changes based on its distance from the camera. To adjust the distances at which these transitions occur, modify the desired field size in the LOD group component. For testing and better visualization, set the LOD range to a smaller values so you can clearly see the transitions. Press play, then open a stats window to monitor trees and vertices. As you move the camera farther back, the building's quality decreases gradually, and the number of trees and vertices in the game drops, improving performance. To make transitions between LOD levels smoother, select the crossfade option in the LOD group settings. Select the crossfade option in the LOD. To make transitions between LOD levels smoother, select the crossfade option in the LOD group settings. And there you have it. The LOD group is one of the best ways to optimize your game's performance. I hope this tutorial was useful for you. Thanks for watching and have a great day.
Wow, it's that easy. Okay. Right, but this means that, yeah, I need to create loads already. And how do I want to proceed? Let's check out the look of Blender.
Import them into Unity. Here's how it looks. The FBX object in Unity. For example, you can create LOD models in Blender, export them as an FBX file and import them into Unity. Here's how it looks. The FBX object will contain several child objects, each with a different level of quality. These objects automatically come with an LOD group component, and you can adjust their settings in Unity Inspector. I'll explain how to use the LOD group component in models in Blender, export them as an FBX file and import them into Unity. Here's how it looks. The FBX object will contain several with an LOD group component, and you can adjust their settings in Unity Inspector. I'll explain how to use the LOD group component different level can more lower and at a fixed point. Select the parent empty game object.
Okay, that's the first time I do a lot, which is going to make things interesting. So I guess I need to start from the beginning here. Because the algorithm is finished, but I need to make a lot. I guess I'm gonna stop the video here and make another one just to organize things. Thanks for watching and stay tuned for other videos and share with your friends.